Hi. An operational amplifier, or op-amp, is fundamentally a device that amplifies voltage with external feedback on and across its terminals. Basically, placing resistors and other components between its input and output terminals defines what kind of amplifier it is. This circuit I have here is a simple voltage follower. Before we discuss the circuit, there are a few things about amplifiers in general I must mention. Firstly, amplifiers are powered components, meaning even though it's not shown on this diagram, a real-world op-amp would need a DC supply, but for this simulation that is not included. As well as this, an op-amp can never output more voltage than what it's being powered by. For this simulation, the maximum output is 15 volts, so if I tried to output 20 volts, I would simply get 15. Op-amps have two inputs. They're called the inverting input, shown by the minus sign over here, and the non-inverting input, shown by the positive sign over here. Now let's start analysing this circuit. In this circuit, I have a DC 5V supply connected to the non-inverting input, and the op-amp itself has the inverting input connected to its output. Additionally, there is a resistor to act as our load with a voltmeter in parallel so we can see what's going on across it. Now if we look at this circuit, we have 5 volts in and 5 volts out. You may be wondering, what on earth is the point of a voltage follower then, if the input is just the same as its output? The reason we use voltage followers is because they provide a high impedance or resistance input and low impedance or resistance output. This might seem a little confusing at first, so let's take a look at the following circuit. This circuit shown here is just a standard voltage divider. If you're not familiar with voltage dividers, then please see the video in the description below. We have a 10 volt DC supply being split in two by two even 10k resistors, and as you would expect, that gives us 5 volts across either one of them. However, let's say we want to add a load on this 5 volt output of say a 1k resistor, like so. Now all of a sudden, we no longer get 5 volts over here, and that's because these resistors are adding together in parallel and completely screwing up our divider. In this case, we can use a op-amp voltage follower circuit. In this circuit, we have the same voltage divider circuit at the beginning with two 10Ks and a 10 volt DC source. The voltage divider input feeds into the non-inverting op-amp input. The voltage divider output feeds into the non-inverting op-amp input. The op-amp has its inverting input connected to its output. And once again we have a 1K and a voltmeter across the output. Now if I start the simulation and look at the voltage across our load resistor, we can see we now have 5 volts. Perfect. Additionally, even if we change these resistor values, let's say both put them up to 100k, and then watch as the circuit changes, we still have 5 volts, 5 milliamps current across our 1k resistor. Overall, op-amps are one of the most quintessential electronic circuit building blocks out there, and a voltage follower, whilst not the most popular op-amp configuration, is a great tool to have in your toolbox. Thanks for watching. Be sure to like the video if you liked it, subscribe if you loved it, and have a good day. See ya.